Okay, so today's video is AI for people in a hurry. And the intention here, if you're just getting your hands dirty with artificial intelligence, you just got ChatGPT and you're using it, or if you're someone already using for some time artificial intelligence, but would like to understand it at a deeper level, know more about it, use it in a better way, or know what other areas of artificial intelligence out there are there to use. And even if you're just curious and you want to learn AI out of curiosity, well, this YouTube video is dedicated for you. And today, while I call this an introduction to AI, well, I'm going to walk you through the A to Z when it comes to artificial intelligence, from the science, from the foundations, up to the tools and the usage where you can actually apply artificial intelligence in everyday life and business. And before we go further, I want to make a deal with you. Give me 20 to 30 minutes of your time. And my commitment to you is that if you do that, if you watch every minute start to finish in this short video, you will be one of the top 1% of people who really understand artificial intelligence. So I hope we have a deal there. And by the end of the video, if I delivered on my promise, do not forget to hit that like button, subscribe to my channel if you're not a subscriber. This will help me do more content like this. And hey, if I go beyond 30 minutes, well, you have the green light from me to badger me in the comment section about it. And with this and without any further ado, the clock starts ticking now for me, and let's get started.
Subscribe to Daddy's channel. The mic.
Let's start with the obvious. What is artificial intelligence or AI? What does that mean really? So let's break this down to its two words. Artificial meaning it's not human, it's machine. And this is obvious enough. And then intelligence. And intelligence represents actions or behaviors that mimics human intelligence. And what makes a human intelligent is our ability to learn, our ability to predict, our ability to solve problems. And these are things today artificial intelligence can do. So in other simple terms, it is machines doing smart things humans do. Artificial intelligence also did not start in 2023 with ChatGPT. It's an old science, and we already had it before ChatGPT. So things like the phone unlock system, things like Siri's weather tips, which is one of the host AIs, but still it's artificial intelligence. The Netflix recommendations. If you watch Netflix and you always get the recommendations that really suit your taste, this is artificial intelligence. And then the navigation systems that we have on our mobiles with Google Maps and similar apps that tell you which is the best route or route to take from point A to point B. And as I said already, intelligence is mimicking the human intelligence. And as we see here, making machines think or act human-like, such as learning, reasoning, and solving problems. These are all features of human intelligence, and now we have them in machines. Now, artificial intelligence is the ecosystem, it's the environment. But within that environment, there are other areas that are part of artificial intelligence but are well worth to know, because everything we have today when it comes to AI is built on them. And you see here in the diagram, artificial intelligence is the concept that encapsulates other concepts within it. And then we have the second layer of artificial intelligence is machine learning and then deep learning. And we already defined artificial intelligence, which is when machines are made to think or act like humans. But what's machine learning? Well, machine learning is how machines learn from data without being told exactly what to do. And this is a big part of artificial intelligence. And then we have deep learning, which is at the core of it all. And it's a special kind of machine learning that uses brain-like structures called neural networks, which we will go into in a second, to learn from lots of data. The major difference between machine learning and deep learning is the use of these neural networks. Machine learning uses mathematical algorithms or models like regression to be able to actually estimate or forecast a prediction based on the numbers it was trained on. On the other hand, to a certain extent, deep learning is the ability to learn but leveraging neural networks. And the difference in deep learning is that it doesn't use these mathematical models like we have in machine learning. It will leverage neural networks to learn from huge amounts of complex data that machines cannot learn when using machine learning. The way I like to put it in the summary is that AI is basically prediction machines. Machines that predict based on the data and the learning that it developed. Now that we understand artificial intelligence, let's look at the history of artificial intelligence. I think this is an important part and gives everyone learning AI context of how and who contributed to the amazing technology that we have today available to most people. Well, the term artificial intelligence was coined in 1956 by John McCarthy and other researchers in Dartmouth College. After 1956, the science kept on going and we had some breakthroughs, minor ones, and the domain of artificial intelligence went through what is called the AI winter, where funding was low, breakthroughs were low, things were super slow, and that lasted for decades. In 2012, there was a major breakthrough in deep learning, where deep learning helped AI master image recognition. And that happened when AlexNet, which is a convolutional neural network that we'll talk about in a second, won the ImageNet challenge. But the biggest breakthrough in artificial intelligence since 1956 up till today, if you ask me, came in 2017 when Google issued a paper called Attention is All You Need, which introduced the transformer architecture, which also we will learn about today briefly. This is the moment that changed everything in artificial intelligence and the capabilities these systems can obtain and can have just by having the technology of the transformer architecture. And this led in short period of time to innovations when it comes to artificial intelligence. So between 2019 and 2022, we got things like BERT, GPT-2, and then GPT-3. And as we all know by now, GPT-3 was the pivotal moment where AI break through from the research labs, from the experts into the public domain to a level where today it's available for billions of people. And since that time, since GPT-3, innovation, funding, investment, as we all know, skyrocketed in the world of artificial intelligence. But the question is, how does AI actually learn? Well, the basic concept is the neural networks. And the idea came from mimicking the brain building blocks to create systems that can learn like humans do. This is the basic concept. And the basic building block of the brain is the neuron that you see over here in this image. So the people behind artificial intelligence who engineered it, they wanted to build a neuron-like structure that enables computers to learn. So we got the artificial neuron or the artificial neural network. And similar to the brain cell, it has inputs as you see here. It has a neuron or a nucleus, something that processes information, and then it has this tentacle which is an output. So things come in, get processed, and it goes out. The same was built into the artificial neural network or the neuron. We have inputs here, x1, x2, x3, and so forth. We have weights, and these are important. Then we have a summation function, and then something called an activation function, and then an output. And the basic way this artificial neuron run is that the inputs are multiplied by the weights, and then they are summed, and sometimes they are summed with something called a bias, and then they go through an activation function. This activation function simply decides if the output will go out or doesn't go out. So this is the basic block of our neural network. Now imagine having billions of this artificial neuron. That what gives us the name networks. So neural networks. Networks is many of them working together. So this output will be an input for another neuron and so forth. This is why we call them neural networks. And with putting billions of them together, like when putting billions of these cells together, we get our artificial brain here while we get our human brain here. And AI learning in this context is defined as tweaking and adjusting the weights to reduce the errors out of the network that is built to a level where it's satisfactory for the people building that artificial intelligence. And these set weights at the end are the defining element of an artificial intelligence models. This is why when we have open source models, sometimes we hear the term open weight models, where actual people can see the weights of the models that were developed by the AI research lab that developed that model. Now that we understand the concept of a artificial neural, and the neural networks that are made of billions of these artificial neurons we looked at, and by the way, when you hear the term, there's a model that is 20 billion parameter, that means it has 20 billion learning parameter values, which can be either weight or bias. So it has 20 billion weights and biases defined for that model. That's just for your information. But as we understand that there are neural networks, What are the high-level types of neural networks out there? There are so many types out there. I'm going to give you the fundamental one that are really important to understand, to have a comprehensive understanding or basic understanding of artificial intelligence. The first one, which is in my opinion the most in use, the most important, is called the feed-forward network. And it's called feed-forward because, as you see and as intuitively when we looked at these neurons, you have nodes that generate outputs. These outputs go as inputs to the next layer of nodes and so forth. And all of them are made in the same way that we've looked at in the previous slide. They have a summation function, they have an activation function, they add bias, and then they get the output. But usually you have so many different layers. This is why the word deep in deep learning comes from. So these are usually deep networks. And as the model is learning, doing all of those calculations, it is tweaking the weights. And by the end of the forward run, so this is beyond the feed-forward networks, something called back propagation is taking place as it's learning. So here the model actually goes backward in the network and looks at the weight values that the forward run generated. And looking at those weight values and then looking at the errors, the model can then adjust the weights as it's doing this back propagation until it continues that reverse path. But the thing to learn here is that this is how a feed-forward neural network looks like. This is a main network structure that is used till today in artificial intelligence models. The next type is the RNNs, which is the recurrent neural network. And this is very similar to the feed-forward network. But here there is something called the hidden state. The easiest way to understand it, it's a memory. It's kind of the network maintaining some level of memory. So whenever the weights are designed as this network is running, the network to a certain extent is able to memorize the value of the previous run. So as the network is trying to learn from the data, it will know the previous value that it had, and it can compare it to other things like the error, basically levels, and decide how tweaking going forward should happen. And again here, it will memorize the value of the previous run, sort of, to contain that memory as the network is running over and over and trying to tweak those weights to get the best possible outcome in terms of learning out of this network. Now, memory is a big deal when it comes in the artificial neural networks, and this is why we have the third type of network, which is the long short-term memory network, which is the LSTM network. And this is a visual mathematical representation of how these nodes look from within. And you can see all of these mathematical coefficients or functions that are designed to help this node to hold pieces of information from even previous nodes and even occurrences in nodes that comes after it. So this is a structure that is very good in maintaining memory across the network back and forth. Last but not least, we have the CNNs, not the channel, the convolutional neural networks. And these are very special deep networks that are good in processing images. And you can see here in this example, you have the number 3. What this special type of convolutional network, which is this part, does is that it breaks this image into certain things called convolutions. And then these convolutions are run into functions called kernels, which is basically functions that play around with the parts of the image. Like, for example, increasing contrast, increasing brightness, things that will help this network manipulate those subsampling parts of the image. And eventually it will go to really small samples that would convert into values that will go into a feed-forward network. The far end of this feed-forward network is actually predictions that could lead to predicting what is in this image here. And for this one that we're looking at, the example would be if you run such a network, at the end, the network will predict the number 3. So what is there in the image is number 3. And this is how image recognition, or OCR, happens fundamentally. Now we're going to focus on the text part of these large language models. And here we're talking about tokenization and embedding. You keep hearing when it comes to artificial intelligence tokens. So this is what we're talking about. And again, here I just need you to bear with me and understand those concepts. I will bring it all together in a second and it will all make sense, I promise you. So tokens are basically words or pieces of words that eventually are turned into numbers. For example, if we want to tokenize the statement ChatGPT is smart, it could look something like that. So some of the words will remain in a chunk as a whole word. Some of them will be broken into one or two or more letters. So it is a mechanism, it's an algorithm that will take a statement and break it to chunks that we can convert to numbers that these large language models understand. At the end of the day, we need to translate words into numbers because all of these models, as we've seen before as networks, they deal with numbers. They cannot deal with actual words. Now let's look at embedding. Embedding is basically giving each token a special number or a sequence of numbers that we call a vector. And the vector is fundamentally the meaning of that token or word or its identity represented in numbers. The easiest way to really describe embeddings, if you have a dictionary that turns words into numbers, that is your embedding, or even we can call it an embedding model. So to simplify it, embedding is our dictionary. It takes the word, finds its meaning, and gives back the model a number for that meaning. Last but not least, positional encoding. Well, models, the way we use them, do not understand the sequence of words in a similar way that humans does. So if we look at ChatGPT is smart, it doesn't see it in that sequence. So positional encoding is basically us giving each token a number in sequence. So the model, when it looks at this sequence, it will understand that chat comes first, and then G, and then PT, and then is, and then lastly smart. So it's simply an encoding that gives positional information for the model about the input. And the way text goes into large language model is that it gets tokenized, it gets its token IDs, and you can see here it's broken through color coding, and then it will get its positional information saying which word or token is associated with which index of that token. So you can see here the example, I am a robot. You have I is 0, then 1, then 2, then 3, and then that goes into a positional encoding matrix, again a sequence of numbers that tells the model the sequence of these words. Last but not least, that text will go into an embedding model. So this is a model here that will take all of the words, see here the objects, object 1, 2, and 3, and will translate them, as we discussed, into vectors of numbers. So each of these objects will come out as vectors of numbers that the model can deal with and the model can understand. This is the most important part, and here everything comes together. This is the transformer architecture that Google gave us in 2017 when they dropped the paper "Attention is all you need." And I will just walk you through what this system does and how it helps us to predict the next word. And that's how we get answers when we speak to ChatGPT. It is predicting the next word and the next word and the next word based on the prompt that you gave it. And what happens here? You push your text, it goes to the embedding, which we already understand now. We get the number representation of these embeddings. That goes forward, we get the positional encoding. So for each word in your prompt, we have indexing. We know which comes first, second, and third, and so forth. And then all of these matrices, all of these numbers that we got in vector stores go into a big matrix, basically a big chunk of numbers that goes to a multi-head attention. This is fundamentally the breakthrough that happened in the transformer architecture. Because we have those associations within these vectors, because we have the positional encoding, all based on the tokenization that already happened, the model here will do so many calculations in parallel and will start associating the words in your prompt with each other. So let me give you an example. If we enter a prompt, the boy sat on the, and we stop there and we enter that to the large language model, here the model will start linking these words together. The boy sat on the. So boy is related a lot to sat. The is referring to the boy, probably. This part does all of these calculations that will help the model know where the attention goes within the input prompt. which words are having more attention in relation to each other. And once all of these calculations happen, that runs through a feed-forward network and then add and normalize. This block here is called the encoder. And this is processing the input. This is what basically gets the model to understand, okay, now I get what this user just gave me. After it's done, it actually moves to this big block here. This is the decoder, and the decoder is actually using the input from the encoder to predict the next word. So it has an input, it needs to give an output, and there's two parts of that decoder. One part, which the first time you prompt, in theory, it doesn't activate. But later on, once the first output comes out, it comes back here. And at that stage, this is run into this part of the decoder, but without seeing the inputs. So this is basically the model looking at the first output without understanding the input. But at this stage here, which you see this link, actually that calculation that happens at this stage with everything that we had from the encoder will be crunched together in this part of the decoder. Again, it will all go through the feed forward. So in case there was an output, it goes with the input. And now the decoder will see, okay, now I understand all of the relations of all of these words of input and some of the output that I previously generated. And now I think the next word will be, obviously that will be a number representation. It will be predicting the next word. And this is what these linear and softmax functions or algorithms would do. They would give the output words and the probability for each of them. And the highest probability will be the output. So if we said the boy sat on the, probably that will go in. This will not activate because still we don't have an output. This part will run and it will crush all of these numbers and will do all the calculations. And the word that the model will predict is mat. The boy sat on the mat. And then the mat will go around and enter here. And then the word after that will come and so forth. And that's the breakthrough in the transformer. It actually can get the model to understand the relations of words together like a human does. This is fundamentally the biggest breakthrough we got in AI. And this is why it was so important and a pivotal moment in artificial intelligence. Now, I just put this up here. If you want to learn more, I have really deep videos about all of these concepts on my channel. If you have the time and if you have the heart and the stomach to go through 2 hours of a video explaining these concepts bit by bit, there's a video with this thumbnail on my channel that breaks down the concept of the transformer and actually goes through step by step in the concepts that lead us even to review the actual paper of attention is all you need. Now, at this stage, you are an expert in artificial intelligence. I guarantee you are already one of the top 1% when it comes to AI. You understand how the technology works. You understand networks, neural networks. You understand the transformer architecture, embedding, tokenization, positional encoding. All of that are things or concepts you understand even at surface level. So to a certain extent, you know about AI now more than most people. Now let's go to more relatable, fun stuff just to know what's going in the world of artificial intelligence, what skills we need, and some concepts that will really be interesting and help you as you navigate your way around artificial intelligence. Now let's go into prompt engineering. I'm going to be quick here. These are probably things you've heard before. So prompt engineering is crafting the right question or instruction to get good answers of AI. Well, trash in, trash out. If you send the artificial intelligence a bad prompt, you will get a bad prediction or bad output. So this is why the word prompt engineering became really famous since the time of ChatGPT. You need to know how to prompt your model to get the best output that you're looking for. And there are recommended techniques when you're prompting. I'm going to give you the top. This is a whole science, by the way, especially if you're prompting for systems, for agents, something like that. It's a whole science. I'm going to give you the fundamental ones that will always make your prompts high quality. The first one is be specific and give context. Don't just ask for something without explaining that thing or that circumstance of that thing to the model. Consider yourself speaking to a stranger. So sometimes if you ask a stranger online, how is the weather? Well, they cannot answer you because they need to know, are you asking about the weather in their country, in their location? Like, what exactly are you asking for? So you need to explain the context of your question. This is what it is. And then be specific. tell the model exactly what you want out of it. Do you want a prediction for the weather? Do you want an explanation of how such a weather forms? Be very specific. Then role play. Tell it to act like someone. For example, you can tell it you are a software developer, or you are an engineer, or you are a designer, or you are even a physicist. And then start talking to it or prompting it. It can help the model put itself in a state that will give you better answers. Give examples. This is a super powerful method in prompt engineering. So if you want certain type of output, you can give it examples. So you can tell it, well, when such an input comes, I need something like that as an output. It will learn from these examples and it will most probably give you something very similar to what you're looking for. And then constrain the format. Tell it, how would you want the output to be received? What kind of format do you want? And now if you're doing coding, obviously you can ask for things like JSON, but also you can ask for bullet points, you can ask for concise paragraphs, whatever you want. But be very clear with the format. Chain of thought prompting. You can ask it to think in steps, to reason through the logic and the steps of your question. Now, this in many cases today happens automatically even without you prompting it. But I still recommend it as a best practice to prompt it when the prompt or the topic you're addressing matters. Reasoning model prompting. Today, models are advancing and they have advanced reasoning capabilities, especially if you are on one of the paid tiers of one of those AI research labs like OpenAI Plus or Pro. You can actually ask these models to do deep thinking. So you can tell it, think deeply about my prompt. That matters. And this is sometimes a way now these models actually get the instruction to activate a deeper thinking mechanism that it already has. Now, something really related, the topic of vibe coding. You might have heard the topic of vibe coding a lot, and it's basically coding with AI, asking AI to create code for you that you can create, fix, develop, and then run and create applications and systems and apps and tools. The term actually came from a guy called Andre Karpathy last year, and he is a co-founder of OpenAI, and also he was the AI director of Tesla. So he's someone knowing what he's speaking about, and the term basically came from him. And anyone can do vibe coding, and this is the important message. You'll have to wait to until the end, my final recommendations. But this is a post that gets me to brag. I vibe coded on Replit. Replit is one of the top sources or places where you can vibe code. I created an application and I published it on X, and the CEO of Replit told me, sick. The second concept to understand in the world of AI is AI agent. So they were calling this year, 2025, the year of agents, and it is. Agents are everywhere. They're developing by all different kind of technology companies, and their uses are really in every domain. I have a video dedicated for AI agents. Again, head to my channel, look it up and watch it if you're really interested in this interesting field. If you look at this image, this is an AI agent that I created just to take this picture and show it to you. And before I explain what you're looking at, the difference between large language models and AI agents is that the LLM, or the large language model, is the brain. So when you interact with ChatGPT, you actually ask it a question, it gives you an answer, and that's it. Well, a model is code, it's software that has the brain of the large language model, but it's able to reason based on that large language model and then take action. So it can perform tasks for you in a virtual world, which makes it super powerful. So if we look at this agent, this is a typical basic, very simple agent setup. It has an input here, so this is how actually it receives the prompt or the input from the user. It can have so many forms of output. Here I just put send a message or send an email just as an example. If I don't have that, actually it will respond directly to the user like an LLM, but it has the ability to take action and execute tasks, and that it can confirm by chatting with the user. For example, here, this is the model. This is the brain of this agent. This is the memory of this agent, so it remembers what it does when it interacts with users. This section is basically tools. These are things that gives the agent hands and legs, the ability to execute tasks, as I said already. An MCP server is basically a technology that enables the agent to gain access to information sources or multiple tools at once without any kind of coding or configuration. So once you connect the MCP server, the agent will talk to it and will know, oh, I have access to 10 tools. You have, for example, this is a calculator tool. It's a tool that gives the agent the ability to crunch numbers. This is an HTTP request, and not to go technical, this nearly will give the agent unlimited access to so many tools that are defined by technology developers out there. And this is just an interesting example I found by chance. This is some kind of DHL tool that will give the agent the ability to track numbers that are shipped by DHL. So imagination is your limit when you develop these agents, but it's a very important concept to understand. It's everywhere now, and we have agents doing work supporting humans in business and in personal life. The concept after that is deep research. The reason I put deep research in its own slide is this is one of the most things I use when it comes to artificial intelligence. This is an agent, so it's an agent-like feature. It has agentic behavior that can autonomously find, read, synthesize information from many sources online and then give you answers to complex queries. It can do research for you, actual online research for you that used to take us hours and hours to do. This can do it for you in minutes. This is something that revolutionized AI, and all of the big players have their own version of that deep research. Some better, some worse. If you try them, you can for yourself tell what you prefer. I have my preference, which is usually OpenAI's deep research. And this is significant. This turns AI into your own personal junior analyst or researcher. And this is super powerful stuff. If you try it once, you will be hooked. Again, be careful with the results you get out of AI, but this can do lots of research for you that will get you to save lots of time and focus on the important parts of whatever area you are investigating. Now, I wanted to keep this as short as I could. Maybe I succeeded, maybe I failed in terms of the timeline of this workshop or AI for people in a hurry, but I am still committed to my goal. I hope you can feel it now that you're already knowing more than anyone around you when it comes to artificial intelligence. My intention is to give you this taste and confidence when it comes to AI for you to go out there and do your own investigation, interact and have friction with the technology and learn on your own. But there are things like browser and computer use. Now we have agent mode on ChatGPT, and this is basically an agent that is able to look at a screen, take screenshots fundamentally, move the mouse like a human does, and even type like a human does. And it will basically navigate the computer like us. This is in its early stages, but super powerful part of artificial intelligence technology. AI images and video generations, all of these ChatGPT images you see out there on Instagram now, all of these Google Veo 3 type of videos that you find out. This is a whole arena of artificial intelligence, really interesting, really fun, really impactful with real life applications when it comes to business and personal life. We have MCPs, which I mentioned with agents. We have RAG techniques, memory and recovering information and breaking down information and memorizing it and offering all of that to AI models and agents is a very, probably the most important, in my opinion, at this time when it comes to artificial intelligence. This is where lots of complexity and importance is when it comes to building AI systems, and super interesting area to learn. So there's RAG techniques, vector stores and memory, and then cache and context. Basically, what is memory as you speak to the model is contained, and what is the context, the complete context of that conversation. This is why today people are arguing we should replace prompt engineering with context engineering. How do you engineer all the tools, access, memory, information, documentation that a model or an agent has for it to give you the best answer? So it's not only about the prompt. And then there's much more. This is an AI generated image like nearly everything that you've seen in this presentation that will show you so many different things. You can see screen use here, vector database, and so more that are AI applications out there that you can go and play with and get amazed with what this technology could potentially mean for humans going forward. Now, finally, if you're not already on a journey, if you just stumbled to this video and now you feel empowered and emboldened to go forward and learn AI and do more there, what can you do? Actually, my basic advice is simply get started. Find an area that you're interested in. That could be simply talking to a large language model, something like ChatGPT. Try to address things in your personal life, then work, and work your way from there. Simply start and try to improve 1% in your knowledge and usage of artificial intelligence every day. I guarantee you, with the knowledge, if you completed this video A to Z, with the knowledge that you now have, you're already the smartest person when it comes to AI in most rooms that you'll be part of. So you're already ahead of the curve. What you need to do is go and drive further your journey. There are online courses. These are amazing. These are nice. You can have all of that for free from people like me, myself, and so many creators like me who are doing this for free on YouTube. So, but if you want it as a packaged kind of course, go to these online courses and pay a little amount and learn. Play with tools. This is the best way to learn. Challenge yourself. Try to build or create something. Make a decision to vibe code a basic website. Go to something like Replit and vibe code it. And then take it from there. You'll start learning and you can use more complex tools. There are so many online communities. YouTube, X, Reddit. Go there. Join these communities. Chat with people. See the influencers in the space of artificial intelligence. Hear their thoughts and ideas about AI today and the future. Believe me, you will enjoy it and you will learn a lot. Well, this is the end of AI for People in a Hurry workshop. I hope that you believe I delivered on my promise and the deal we made in the beginning. I hope you got the value that you were looking for when you invested the time watching this video. If you did, please do not forget again to hit that like button, subscribe to my channel. I hope you support it and you enjoy my content, and share it with others. Big part of what I'm doing is I'm trying to benefit people out there, and I hope you can do the same and benefit people around you by sharing this video with them. And with this, thank you for watching and goodbye.
Subscribe to Daddy's channel. Give me the mic.